Hello, this is Node.js and browser applications with ArcGIS REST JS. I'm Allison Davis, and I'm here with Noah Mulfinger. And if you'd like to follow along with this presentation, there's a link to our slides there in the title slide. So here's kind of an overview of what we'll be talking about today. First of all, just what is REST JS and how and why this library came into being, who's using it, and for what kinds of projects. We're going to talk about what's new in 2020 since the last time we were all together at Dev Summit. And we'll take a look at some common patterns that you'll see when implementing this library in your project. And then we really want to spend the bulk of the time really digging into some demos and code, both in browser apps and in Node applications as well, to really see how this library is working and how you can start implementing it in your own projects. And REST.js is completely open source. You can pull our repo down from GitHub, and we also have the documentation URL here as well. The docs are completely open source as well. The API reference is generated automatically from comments within the code, and then we've also got a lot of guides and demos at the doc side as well. So pull requests, suggestions, ideas for improvement, all welcome, appreciated, and encouraged. So please reach out to us. So in a nutshell, ArcGIS REST JS helps you talk to ArcGIS Online and Enterprise from modern browsers and Node.js. So what does that mean? We try basically with this library to handle as many common use cases and as many idiosyncrasies of the REST API as possible so that you can concentrate on writing code quickly in your application. So for some context, here is what a vanilla HTTP request to the ArcGIS REST API looks like. So this is just straight up HTTP in a browser with no helper APIs, polyfills, anything like that. So first we have to construct the URL, and we have to not forget to tack on an f equals JSON parameter. And then we're making a new instance of that HTTP request. We're listening for on ready state change. And once we get that ready state back, then hopefully we have some response text to deal with in our application. If we don't, then we need to figure out how we want to handle errors and step through all of those use cases ourselves. And then, ideally, it's not great. It's certainly doable. Definitely something that you can implement yourself in an application, but there's a lot of edge cases to take into account, a lot of overhead, and also our code is just not terribly readable here. So here's the same request using the fetch API, and this looks a little bit more readable. It's a little bit terser. We've still got our URL up at the top. We call fetch and pass that URL and then an object with some options. So we set the request type to post. We append the correct header. We have to also be sure to concat and encode our parameters, still append that f equals JSON parameter. And then we get a promise back. And then if we get a response, then we can dig out that JSON and start working with that in our application. There is some error handling provided, but we still have to do a lot of that ourselves. So this is, like I said, a little bit more readable, but still can be pretty tricky, especially when it comes to that error handling. And then there's even more complexity going on, right? So what are all the different error codes that we need to account for? How do you handle authentication in your requests? How to encode dates or proper encoding for objects? How do you manage tokens for federated servers and refreshing authentication when necessary? So the goal of REST.js is to handle as much of this as possible so that your head doesn't explode. So here is that same request using the REST.js library. We import a request from the library. We call that request, pass it the same URL that we had set earlier, and then we await a response. We can catch an error, and then we can also step through different cases of errors and handle them accordingly, and then kind of do a default handle a regular error at the end for any additional problems. So REST.js is doing a lot more than either of the previous examples in much fewer lines of code. We can really see clearly what's going on here, and this is super nice and simple. So there are a lot of value adds that REST.js tries to bring you when working with this library. Automatically, the library is appending that f equals JSON parameter that you always have to have. It's also appending request headers for you. It's encoding query string parameters right out of the box. You can work with different kinds of data, including images, encoding form data. Clear and informative error handling. That's something that's really important for this library and one of our top priorities. Proper parameter encoding, support for authentication, including tokens for federated servers, refreshing auth when necessary. But where the library stops is really at the request level. So we don't handle things like mapping, client-side analysis, what you're going to see in your application or kind of that display layer. We really focus on transactional data from the REST API. And if you're looking for more sort of those client-side features, definitely the JavaScript API is going to be a better fit for your application. So a couple more notes about request. Request only expects a URL, but it does expose request options as well. So if you want to dig in there and you need to customize your request, you can do that really easily. The HTTP method defaults to post, and handling the iRequest options, you get a lot more control over the request. You can pass in any additional parameters you'd like. And as you can see, those can be anything. They can be strings, Booleans, numbers, you can hand over a file, you can use a date object, all of that is just handled out of the box. And then also you can pass in inside the options, you can work with authentication, you can, if you need to change the headers, you can dig into that, and you can even pass in a custom fetch implementation, which can be really handy if you're working with other third-party JS libraries. So the rest of REST.js builds on top of that request package. So for example, this is what the geocoding package looks like. We import geocode, and so for example, we just call geocode and then the string LAX, and we wait for that response with our promise. And under the hood, geocoding is just calling requests, but with nicer syntax, so it's really clear in your application. But iRequest options, that interface is still available to you if you need to specify anything. So under the hood, same request, and you still have access to those options if you need them. So the overall goals of the REST.js project, this library needs to work in Node and modern browsers with as small a set of polyfills as possible. We want to keep this as small as possible for best load time and performance in your apps. And we really want to keep this framework agnostic so that you can use REST.js and just drop it in with React, Angular, Vue, vanilla JavaScript, whatever you're using to write your project. Also, we want to keep the rough edges of the REST API away from your application code and handle these edge cases and kind of unusual use cases that the REST API can bring up so that you don't have to deal with that in your application. And lastly, the library really wants to align with the JavaScript ecosystem. So whatever your tooling, whatever bundler you're using, whatever frameworks, whatever your tooling and config looks like, you can drop REST.js into your project without having to use any additional plugins or config. It'll just work. So a disclaimer with all that in mind. Definitely, this is not an official product, so there's no official roadmap or anything like that. It is definitely a work in progress. And we're kind of scratching our own itch with this project. And what I mean by that is that this really started as a way to standardize functionality and utilities that different Esri teams had created in order to work with the REST API in their own projects. And this was the main reason why it was decided to open source this library was that if Esri teams were coming together and adding so much value due to their own different use cases and implementations, then definitely partners and users of our products can do the same thing. And so this has turned into a really rich collaboration. So again, kind of a comparison, you could say this is similar to the Python API and functionality, although it does lack a notebooks environment, such as Jupyter Notebooks, where you can save and rerun scripts. And this is very different from the ArcGIS API for JavaScript. Like I said, this is all about transactions with the data from the REST API. So no mapping, no display capabilities or data analysis, really focusing on just requesting data and then being able to do something with that data in your applications. So in the beginning, RestJS has been around for just over 2 years now, and it began as a collaboration between ArcGIS Hub and the ArcGIS for Developers team, as well as some customers. And Hub was using Ember and had experimented with open sourcing some of the wrappers that they'd created for working with the REST API and dealing things like users and items. But when they did that, they found that their solution was a little too specific. It was a little too specially designed for their use cases and Ember, and it was difficult for users to grab and go and kind of run with that. And the developer experience team was using Angular, still is, and a lot of the functionality that we had written was really similar to that of the Hub's team, but specific to an Angular context and the conventions of Angular applications. Both Ember and Angular can get pretty opinionated. So how to create a solution that could eliminate that duplication of work, kind of generalize things enough so that these helpers could be written once and work everywhere. And as of 2020, we've seen the floodgates open, not only with customer implementations using this library, but other teams at Esri. And these are just the teams and collaborations that we know about. So Hub, developers, the Story Maps team, Web App Builder and Experience Builder, ArcGIS Urban, Professional Services, ArcGIS Solutions, ArcGIS Enterprise. I mean, the list goes on and on. We've also seen collaborations with startups, partners, customers, and hopefully with you as well. So now I'm going to hand things off to Noah. He's going to delve into a little bit more about the individual packages and some common patterns that you'll see when using them in your applications. Noah?
Thanks, Allison. So this is the set of packages we have so far in the REST.js library. We have the base request package that other packages build on top of. Auth contains different methods for handling authentication, user session, tokens, etc. Portal is for interacting with users, groups, and items in ArcGIS Online or your enterprise portal. Feature layer is for querying and editing data in a feature service layer. Service admin is for managing metadata about a specific service. Right now it only contains functionality for dealing with feature services, but it's meant for things like creating a new service, adding layers or other properties to a service. Geocoding and routing are fairly self-explanatory. They provide wrapper functions for using the geocoding and routing services and their various functionality. As you can see, all these packages are very lightweight. They are also set up to be tree shakeable so that if you are using a bundler like Webpack, you can only bundle the functions you actually use. Now I'm going to talk about some common patterns. So for functions that only require one piece of information, they can take in that info directly as a single argument or as part of a larger object. In this case, if you just wanted to do a default query of ArcGIS Online for items containing the string water, you could just do the first query with passing in just a single string. You could alternatively pass in an object containing a query field and additional options such as authentication, a different HTTP method, or things like portal if you want to access something other than ArcGIS Online. If more than one piece of information is needed, you would always pass in an object with the set of required options. For all functions, the object you pass in extends the default request options provided in the base request library. So you could pass in authentication, headers, etc. to the delete features function as well. So just show an example in the documentation. Here's the delete features function that I just showed in the previous code snippet. So if we scroll down to the options, you can see the required parameters, object IDs, and URL listed at the top, as well as some optional inherited parameters like authentication, which I mentioned earlier, fetch if you want to pass in a custom fetch implementation, as well as some other common parameters you might want to use in a request. For additional custom parameters, you can use params here, which will take in any key and any value. This is here because the goal is not to document every possible parameter available in the REST API, just the common ones that people are using with this library. The functions in this library also try to reduce the overhead of constructing a URL and require as little information as possible from the user. For example, in this setItemAccess function, we only need the ID of the item, the access value or who it should be shared with, and some authentication to know if the current user is allowed to update the specified item. This way, you don't need to construct the full URL with the correct portal and the correct folder paths to make this request. Overall, the focus is on simplifying the developer experience, even when the underlying logic can get fairly complicated. So we do things like ensuring the response is deterministic and figuring out which URL to call based on the user's role and authentication, as I showed in setItemAccess. Here's kind of a pretty complex example of how under the hood this library is handling some of the complexity for you. So this is the change group sharing method. It'll handle sharing, adding sharing to specific groups, removing sharing from specific groups. And under the hood, it's doing a lot of work to determine what the URL should be, and if the user has the correct membership in different groups to share an item, and throwing helpful error messages when sharing or unsharing doesn't work correctly. So yeah, this is just a kind of the most complex example, as I mentioned, but just showing you kind of some of the value added when using this library versus the REST API directly. Another important concern when working with the REST API is authentication. The most common method for doing this through REST.js is through a user session from the auth package. So using either ArcGIS Online or an Enterprise portal, you can construct a user session with the standard username and password credentials. This by itself won't fetch a token, but it sets up the config needed for making authenticated requests. It's similar to the JS API Identity Manager, if you're familiar with that, in that it stores a specific set of credentials. However, it doesn't handle multiple portals and doesn't present a UI to log in when a non-authenticated request fails. The user session serves as an authentication object that you've seen passed around and used in previous code samples. This authentication object is passed into the request function, and the first time a request is made with it, it will handle getting a token from the server, as well as checking whether the server is trusted or federated. And on subsequent requests, using the same authentication, it will reuse the same token if it hasn't expired. And if it has expired, it will automatically grab a fresh token from the server. We'll go over some more complex authentication patterns like OAuth in some of our demos later. Since the previous version of this talk in Dev Summit 2019, the library has been fairly actively developed. We've released a 2.0 version, and there have been 20 plus additional releases beyond that over the past year. So it's been pretty active. I'm going to go over a few things that have been added in version 2 and so show some quick examples. So we added a new search query builder class that allows you to easily compose a search query without needing to do a bunch of manual string management. We also added some improved paging functionality, including a next page function that is returned from any search query that you make. So that allows you to easily call the next page of results and get those results without having to construct a new request. We've also added two helper functions, set default request options and with options. Set default request options allows you to set custom options for all requests. So anytime any request is made, it'll always have those options. It's useful for things like request headers that will likely need to be with every single request. With options allows you to set custom options for a specific request. For instance, if you wanted to create an authenticated version of a request that you can call, and you don't need to pass the authentication object to it every time. There's also a bunch of reorganization of packages, types, and functions based on feedback and the needs of contributors. So this is an example of creating a search query using the new builder class. In standard queries, you would need to construct the query as a long string. As you can see in the 1.x version here at the top. In version 2, you can build up a query using a set of helper functions. This is especially useful for complex queries or ones that require a lot of conditionalization. So as you can see, you can do have a match in a specific property. So .match US Forest Service in owner is equivalent to specifying that the owner has to be US Forest Service, as well as start group and end group work as creating a group with a parentheses around it. So it definitely makes things a little more explicit and less manual string management. One example of the package reorganization is just grouping up the separate items, users, groups, and sharing packages into a single portal package. These packages all shared a lot of functionality, and they were already very small. So grouping them up didn't increase the size too much, and just made things a little clearer, so you didn't have to import 4 different packages in some cases. For those using TypeScript, one improvement that was added was including types in the same packages where they were used. Previously, you would have needed to install a separate common types package for a lot of the TypeScript types, but now it's usually just one import, and so that also reduces the number of packages you would need to install. And for the full list of changes in the 2.0 version, you can check out the release notes. So now I'm going to hand it off to Allison. She's going to start showing some demos. Allison?
Okay, so next we're going to take a look at some demos. And the first demo we're going to dig into is using OAuth 2 in a browser using REST.js, REST.js's auth package. So this is a vanilla JavaScript and REST.js implementation of this pattern. And the first thing we're going to do is just demo the application itself. So a pretty straightforward little UI. So we're just going to click this sign in with inline redirect. And we're going to hit allow. And now we are logged in as Array Davis 49. So what's going on under the hood is that this app is using ArcGIS account credentials to log in by proxy using OAuth 2 and the auth package from REST.js. So let's take a look under the hood. The first thing to note is that we're actually, for this application, we're using the CDN to access our packages. And so to use the CDN, all you need to do is go over to the API ref links on the documentation website, and the links to the individual packages are right here in the doc, and you can just copy and paste and drop that in. Same with request. Great. So the next thing I want to note is how we configure our application to use this pattern. And so what you'll want to do is log into the developer's website. So I'm already logged in here at developers.arcgis.com. And I've created a test application, REST JS test. And under authentication, there's two important things. The first is you'll need to grab your client ID from the credentials section. And I'll show you where in your code you'll be using that value in just a sec. And then you'll also set redirect URI, and that is whitelisting a URL to redirect users to after the application is authorized to use ArcGIS Online on the application's behalf. So I've whitelisted a couple of ports here since I'm just running this demo locally. And the next thing we're going to do is take a look at the code. So here we are inside of our demo application. We've got our index.html file that we're going to start with. And so if we scroll down the page a little bit, you'll see first we have some script tags that I want to point out. First, we're just linking to config.js. This is just inside of the root level of our application. And if we pop over to config, this is all we're doing here is setting the client ID, and this is the value that I pointed out on ArcGIS for developers. So this is the value that you'll copy over from your application that you create and just paste that into your application. And then below there, these are the unpackaged CDN URLs, first for the request package and then for the auth package. Those are the only REST.js packages we're using inside of our demo application. And then if we scroll down a little bit further, here you'll see we're setting redirect URI. More on that later. And then if we scroll down a bit further, let's see. There we go. So this is the inline redirect button. So rather than opening the redirect in a pop-up, this is the inline version that we demoed in the browser just a moment ago. And all we're doing is just with vanilla JavaScript attaching an event listener to that button. And here you can see, this is important to note, all of when you're using the CDN pattern using REST.js, you want to prefix everything with the ArcGIS REST namespace, and then .user session, and we begin the OAuth2 workflow. And we're just passing in the client ID, so this is the value from the config file, the redirect URI, this is the URI that we set earlier up in our code, and then we append authenticate.html. So this is where the user is going to be redirected as this OAuth workflow continues, and then plus the client ID. And then we just set pop-up to false. You can leave this blank and not supply this param at all, and then the pop-up version of this workflow will take place. And otherwise, if you want to do it inline, you just set pop-up to false here. So what happens next is once the OAuth2 process begins, the user is actually redirected over to authenticate.html. And all this is actually is a script. You see again, here we have our CDN links and our script tags. And then down below, we're running this function process authentication. And all this is doing is, again, we're calling user session to complete that OAuth2 workflow. And we're handing that client ID back. And we're also setting in local storage our session info so that that's available and that the session is preserved in the browser session. So if we take a look at our browser again, and we just sign in with our inline redirect, we allow, and now we're logged in. And if we crack open our console and scroll over to local storage, we see that sure enough, our session info is getting set in local storage. And if we hit sign out, then as you can see, local storage is cleared out and the application is logged out. So you can find this demo code on GitHub right here. The link is in the slides, as well as the link to the CDN and the auth package documentation if you're looking for more info about implementing OAuth 2 and REST JS in your applications. So the next demo I want to show you is built in React, and it's a geocoding component that was actually created by an Esri user, and a link to his repo is here in the slides. And I'm running this locally just to show the upgrade to the most recent version of REST JS. So this is built with React and also with Downshift, which is a project to create low-level, pretty primitive, accessible dropdowns, menus, and other components in React. While leaving them pretty unopinionated style-wise. It's a pretty cool project. There's a link here to check out their documentation if you're interested in learning more about that. So here's our component running locally. And all we're going to do here is just type in an address. And as you can see, as I'm typing, the geocoding service is providing me some suggestions. And once I choose an option, then I get my geocoded result back and it pops up in an alert, and I can see my address of 1111 Southwest Broadway, which is the Portland Center for the Performing Arts here in downtown Portland. So I'll just hit OK. Okay, clear that. And now I'm going to show you what's going on under the hood in our code. So here we are inside of our React app, and as you can see up at the top, we're bringing in React and Downshift, and then we're also bringing in geocode from the geocoding REST JS package. So if we scroll down a little further here, the first thing that I want to highlight is here. This is our menu component, and down a little bit further, we have this geocoding component. And what the geocoding component is doing is actually in this file here. And this is where we're getting our suggestions as the user is typing into the input. So a little further down, we have this make network request function. And you can see that this is wrapped inside of a debounce call. And what this allows us to do, it prevents an API call with every single keystroke. So it's kind of a poor user experience, as you're typing and typing quickly, for the API to be, for us to be firing off call after call to the API. That can really make a big dent in performance and really gum up our application. So what this does is slows that down and kind of delays all of that. So by slowing down performance, we actually ironically speed it up a bit. So this debounce method is being imported via Lodash. There are a number of libraries that handle this kind of effect for you, so you can just import that from an open source library and bring it into your project really easily. So next, we're calling the suggest method from REST.js. And all we're doing here is passing the address, and then in this params object, we're setting a center location from which to start with and a maximum number of suggestions. And then we're actually using set state, which React gives us with React hooks, to handle our response from that suggest call. And then bouncing back to our geocoder component, so we're getting our suggestions from this geocode component. Now, if we scroll back up to the top a bit, we have this handle state change function. And so what this is doing a little bit further down, where actually the whole geocoding component is wrapped in this downshift. And we're actually saying to listen to on state change and then passing in this handle state change function for every change. And so we have this selected item, and if there's a selected item, this is our result from our suggestion that a user has just clicked on in order to actually geocode. The other thing I want to point out is that we're using the magic key value from the suggestion rather than just the address string. Suggest provides magic key values in addition to the text string or text result, and the key links a suggestion to an address or place, and that magic key in turn can be passed to the geocoding call, and that improves search time. It's important to notice just when using this functionality that magic keys don't persist across versions of the World Geocoding service, and therefore you shouldn't store those by a client application for any reason. You should just use those kind of in tandem, getting magic keys from the suggest call and then passing those on to a geocoding call in order to improve search performance. So as you can see here, we just call geocode, which is, again, what we've brought in from REST JS. And we're passing in that magic key. We're saying max locations of 1. So if for some reason there are 2 matching results from the geocoding service, we're just going to display 1 in that alert. And then we're getting a response back. And we're just doing a browser alert. And in this alert function, we're doing response candidates, and just for good measure, we're just saying take the first result in that list of candidates and displaying the address in our alert. Okay, so that's our React demo. Once again, you can find the original component repo at this URL here, and also links to both the geocoding package documentation on the REST.js doc site, as well as documentation about downshift and bringing that library into your code are available on the slides. And now I'm going to hand things back to Noah, and he's going to take us through a couple more demos, including working with the JS API and getting into Node.js.
Thanks, Allison. So for my first demo, I'm going to show an example of using both the JS API and REST.js together in an Angular application. So this is a simple application that will display a list of feature services owned by the signed-in user and allow you to display them on the map below. So first, I'm going to sign in. Cool. And so now I have a list of the feature services associated with the account I signed in with. And you can add each of these feature services to the map. So once it gets added to the map, I have the map zoom in to the extent of the feature service so you can view it easily. I'll do the same with Central Park data. Cool. And so now it zoomed over to Central Park. And so that's pretty much the extent of the application. In the list of feature services here above, it's using REST.js to sign in and load the list of feature services. And then obviously the JS API is being used to actually display the data on the map. So let's go ahead and go into the code. Okay, so this is the structure of the app. There's the item list component, which contains the list of feature services. There's the map panel, which contains the JS API map. The authenticate component is for returning from the OAuth 2 sign-in. The view is just a wrapper function. And then there's the session service and item service. The session service works as a store of the session, so it can be easily passed between the list and the map. And that's similar for the item service. It stores the current item. So when you select an item in the item list, the map will know and will update. Okay, so let's go into the session service. So in the sign-in function, we begin the OAuth 2 process, which will go out to ArcGIS Online and ask the user to sign in. And then on the complete sign-in, it returns a session that we can then store in local storage, so we don't have to do it on every page refresh. and then stores the session in this service. And then in the item list component, um, it subscribes to the session from the session service. So it'll, anytime there's any changes, it'll get the updated session. So then we check if the session does exist. Then we construct a new search query using the search query builder. So for any items that have the owner of the current user and have type feature service. Then it uses the portal package to do a search items request, passing in the query and the user session as authentication. Once we get the results back, it sets the results to the items variable, which is used to display the list in the HTML. And in the map panel component, we set up all the interaction with the JS API. So first, it sets up the map, just adding the basic dark gray base map. One thing I'll note is that we're using the load modules function, which comes from the Esri loader. This package allows you to load in the JS API modules without having to manually add the script tag to the page. It'll handle adding the script tag for you whenever you call load modules, which is kind of handy when you're working in a framework like Angular. So it sets up the map. Then it also subscribes to the session service the same way it was done in item list. And when we get a session, we go to the handle session function. And so what that does is it loads in the identity manager from the JS API. And if the session does exist, we register it as a token. And there's a handy method on all user sessions called toCredential, which converts the user session from the user session into a format that can be used by the identity manager. So once we call register token here, the map is now authenticated so it can load private feature services from the logged in user. And so anytime the user selects a item from the list of feature services, it'll call add feature layer. And so add feature layer will load in the feature layer module, create a new feature layer based on that item, remove any other existing layers on the map, and then add this new layer. And then once the layer has been added to the map, then we zoom in to the extent of the item. The last thing I'll mention is that there is an inverse function to session.toCredential called fromCredential, and that allows you to convert authentication the other way. So you can go from a token from the identity manager and convert that into a user session. So if you were to log in through the JS API, you could also pass the authentication to the REST JS library as well. Okay, and that's all I wanted to show for this demo. I'm going to switch gears a little bit and show a demo of REST JS in Node. So this demo deals with searching for and deleting items in ArcGIS Online. So I'll go ahead and start up the demo. So it asks me to sign in with my username and password. Okay, now I'm signed in, and it asks me to do a search query to search for specific items, and then also prompts for item type that I should use. And then as well as tags, but I'm going to skip that. And then I'll select 2 items, so it'll show me 2 different ones. So and then for each item, it'll give me the option to delete the item. So I'll have to go ahead and select yes. It'll delete the Node app 4, yes, and it'll delete the Node app 2. And so now both those items have been deleted from ArcGIS Online programmatically. Let's look at how this demo works. So first we import all the functions we need from the REST.js auth and portal packages. Since the packages are all exported in both browser and Node versions, we can just import them easily into a Node script. At a high level, the demo runs an authenticate method, and then once it gets the user session back, it does a search for items based on the user's inputs, and then goes through each of the items, allowing the user to delete or not delete the individual item. So first I'll go to the authenticate function. In the authenticate step, we prompt the user using the prompts package, which makes it easy to set up command line prompts through Node. So we do a prompt for username and prompt for password. And once we get those back, we construct a user session. And then we do a call to get user. We don't actually use the results of this call, but it forces the user session to generate a token in order to make that call. So now we are guaranteed that the session contains a token as well as just a username and password. And then afterwards, we just directly return the session. And the session can be used in subsequent calls. So then in the search for items, we prompt the user for text they want to search with, the item types they want to search with, and the tags, as well as the number of items they want to return. So we make the prompts, and then based on what we get back, we construct a new search query using the search query builder for items that are owned by the user and that match each of the prompts. So we grab the types as well as a query group for any tags the user has input. And then we add a .match for the search text. So then finally, it does actually makes a call to search items using the authentication of the session and passes in the query and the number of results we want to return. In the delete items step, we use an async iterator to go through each of the items and delete them. We're using an async iterator because each delete is a promise, and so we need those to happen in sequence, so we can iterate through them asynchronously. The delete item step just sets up the async iterator, and then for each individual delete item, we log out all the properties of the item so the user can decide whether or not to delete it. And then we prompt the user for whether or not they want to complete the deletion. And if they do, then we call remove item from the portal package, and that just requires the item ID and the authentication of the user session. And so once that remove item is complete, then it just moves on to the next item. So that's it for the Node.js demo and the two demos I wanted to show. So now I'm going to hand it over back to Allison.
Alrighty, so that wraps up our presentation for today. There are a lot of great demos in the REST.js repo and beyond. We've pointed out a couple here. We also have a link to our slides in case you want to double back and you've missed any URLs. Once again, a link to the REST.js GitHub repo and docs site, and also a cool demo that John Gravois, one of the original creators and maintainers of REST.js, made a really cool kind of Jupyter Notebook-esque demo of some of the functionality in REST.js. So check that out. And then a couple other neat demos here. There's Sapper, web components with stencil, even using Lambda functions. And once again, I just want to reiterate that REST.js is open source. The team totally welcomes PRs, feedback, and information about how you're implementing this in your projects or what you'd see the library, what you'd like to see the library go further with. So thank you so much. Feel free to reach out to us on GitHub and beyond, and have a great day.